Hello student, welcome back to my channel. Today also we are going to discuss very important topic from chemical kinetics, which is a physical chemistry and second year topic, which is nothing but a how to calculate the overall activation energy for a parallel first order reaction like that. So we are going to calculate overall activation energy, overall activation energy, overall activation energy. Within bracket I am writing E activations overall activation energy for parallel first order kinetics, parallel first order kinetics. We are going to calculate this one. Now, let us look at what is the parallel reactions. If you look at the parallel reaction, like A is converting to B with a rate constant K1 and A is converting to C with a rate constant K2. Both are first order reaction. A is converting to B with a rate constant K1 and A is converting simultaneously with a rate constant K2 into C. Then from there I can write down the rate of disappearance of A, which is nothing but a minus dA by dt, change of concentration of A with respect to time, as the stoichiometric coefficient is 1, then the rate of disappearance of A will be nothing but the overall rate of the reactions. So now minus dA by dt, that is nothing but the rate of disappearance of A, which will be equals to K1 into concentrations of A after time t plus K2 into concentrations of A. This is the idea. Now if you look at, if I take the A common, then what I can write down? I can write down immediately K1 plus K2 into here concentrations of A. Now K1 K2 I am writing K overall will be equals to K overall into A, where the K overall will be equals to K1 plus K2. This is the idea. Now from this equation we want to calculate the overall activation energy will be equals to how much? Suppose A to B converting, here activation energy is EA1, here converting in K2 rate constant, in this direction activation energy E2. That means my E1 is a activation energy for A to B conversion, whereas EA2 is my activation energy for A to C conversion, because simultaneously both the reaction is happening parallelly. A is converting to B as well as A is converting to C. Now K overall equals to, we got it, K1 plus K2, whereas EA1 activation energy is A to B, EA2 is activation energy for A to C. Now here I am writing EA is a overall activation energy. This is a overall activation energy. Now what will be the relation of overall activation energy in terms of a K1, K2 and EA1 and E2? That is our motto from this equation. How can I find out? They will provide you E1 value. What they will give you? In the questions, K1 will be given, K2 will be given, and then your EA1 will be given, EA2 will be given, and then what they will ask, E overall will be equals to how much? That is our intention. How can I find a relation between K1, K2 and in between EA1, E2 and EA overall? Already we know K overall will be equals to K1 plus K2. That we will capitalize and we will derive the relation between overall activation energy as well as EA1, EA2, K1, K2. Let us look at into that one. Now if you look at, then this relation, if I write down, K overall will be equals to K1 plus K2. Just now we got this one. Already from the Arrhenius equations, what do we know? K is a rate constant, A into Ek power of EA by RT, activation energy by RT. This is Arrhenius equation, where A is a pre-exponential factor, pre-exponential factor, and you know a will be depend on two factor. What is nothing but a will be equals to that p into z. P is a steric factor, z is nothing but a collision frequency, number of collision per unit time by per unit volume is a collision frequency. So now that is another discussions, another video in elaborately I will give you that one, Arrhenius equation and all those points. So then K will be equals to A into Ek power of Ea by RT, where Ea is activation energy, R is universal gas constant, T is a temperature in Kelvin scale. Now immediately, so then what we can write down, K overall equals to, I can write down over here, K overall equals to, I can write down here itself, A into Ek power of E overall by RT. Instead of K overall I am writing. Yes or no? Instead of K1 what I am writing? Instead of K1 I am writing A1 Ea by Ea1 by RT. Because temperature is same, both same conditions reaction is happening. So that's why temperature is same from both the direction as well as for the overall. And then immediately here what I can write down? A2 into E minus Ea by 2 by RT. This is I am writing. Instead of K2, by applying that Arrhenius equation, I am writing A2 into e to the power minus Ea2 by RT. K1 equals to A1 into e to the power minus E1 by RT, where overall equals to A into e to the power Ea overall by RT, where A is a overall pre-exponential factor, where A1 is for that A2V conversion for that pre-exponential factor, where A2 is a A2C conversion for that reaction pre-exponential factor, where Ea is a overall activation energy, where Ea1 is a activation energy for A2B conversion, where A2 is the activation energy for A2C conversion. Now what I am doing over here, differentiating with respect to t, then that means what operation I am doing? ddt I am doing. Operation is what is operation? Operation is nothing but a ddt I am doing, differentiating with respect to, this is my operations I am doing. Already we know that ddx of e to the power ax will be equals to a into a power of ex. This is the formula. So now we will apply that one. Now immediately if I do that one, that is a, and this part already will be there, e to the power of Ea overall activation energy by RT, and then the constant term will be there minus Ea by R, that part, and 1 by T is there. With respect to 1 by T, if you do, that will be equals to minus 1 by T square. We will get this thing. Same way you do that side also, we will get here A1 minus Ea1 by RT, here also minus Ea1 by R, and this is also minus 1 by T square, and then here also plus A2 e to the power of minus E2 by RT minus of Ea2 by R and minus of 1 by T square. Now if you take this minus, this part will be common, and RT square, if you take common this RT square here and this RT square here, RT square here, RT square will be what? Cancelled. Now ultimately instead of that again I am putting K overall. Instead of that I am putting K overall, and this is nothing but your overall minus, it is a plus, that's why activation energy overall we got. Instead of this part I am putting nothing but a K1, and now you look at here minus plus, then it is getting activation energy Ea1. Again instead of this part I am putting nothing but what? K2, because instead of K2 I write down this expression, instead of K1 I write down this expression, instead of K overall I write down this one. So that's why instead of this, because basic idea K overall equals to what I write down? I write down A into Ek power of activation energy overall by RT, this expression. Instead of K1 what I write down? A1 into Ek power of Ea1 by RT, this expression. Instead of K2 what I write down? A2 into Ek power of Ea2 by RT, these three expression. Now instead of that place I am putting that one, instead of this one I put what? K2, and then minus plus, that's why this is nothing but a Ea2. Now immediately from this equation what we can observe? We can observe activation energy overall will be equals to K1 EA1 plus K2 EA2 divided by K overall. So then this will be equals to K1 EA1 plus K2 EA2 by K overall is nothing but a K1 plus K2. That will be your idea. Yes or no? So activation energy overall will be equals to K1 EA1 plus K2 EA2 by K1 plus K2. Like that. Is it clear? I hope able to give you clarity. What I did, I just write down in form of a, first I write down the relation between K overall and K1 plus K2, and then I apply charge the Arrhenius equation. Then I did the differentiating with respect to T. Then again that what will be the A into e power of activation energy overall by RT, that term for every cases I convert to the in terms of rate constant, and then finally we derive this expressions. Is it clear? So like that, if they give is how many number, like suppose they are giving a parallel reaction like this, समझा करो यार, A is converting to B, A is converting to C, A is converting to D, A is converting to E. Here the rate constant all are first order kinetics, K1 plus K2 plus K3 plus K4. So then immediately what I can write down, I can write down K, same logic if I apply, K overall will be equals to K1 plus K2 plus K3 plus K4. Then immediately what I can write down, activation energy overall will be equals to K1 EA1 plus K2 EA2 plus K3 EA3 plus K3 K4 EA4 divided by overall rate constant, which is nothing but a K1 plus K2 plus K3 plus K4. The same methodology, the way I do it for two reaction parallel reaction, I can do n number of parallel reactions, same idea. Ultimately we will reach what? Activation energy overall will be equals to K1 E1 plus